Hello and welcome. My name is Giselle Gomez from Intel, and I'm here to give you an introductory tour of the graphics optimization tools available within Intel GPA. Intel GPA is a suite of tools that can help you analyze your graphics applications, ranging from games to multimedia applications. These tools expose both hardware and graphics API level metrics to analyze and profile your application. Additionally, Intel GPA offers debug capabilities to allow for quick identification of rendering inefficiencies and reduce iteration time during development. For the 10,000-foot view of your application and its impact on your system, use Intel GPA's real-time performance tool, System Analyzer. It collects real-time performance information across the system and comes in two flavors, a standalone tool and a heads-up display or HUD. System Analyzer provides system-wide and per-process metrics that can be used to determine what the system is doing and how your application impacts it. These metrics compared with real-time overrides to develop an initial assessment of the bottlenecks that may exist for certain scenes within your application. For instance, using the 2x2 texture override will replace all textures in the current scene with a texture of 2x2 dimensions. This can help determine whether large textures are inhibiting the performance of your application. Any one scene, however, can have a diverse set of bottlenecks, and focusing on only one of these real-time overrides may not provide all the information needed to fully understand the contributing factors when evaluating game performance. The standalone version of System Analyzer shows all live metrics and overrides in a separate window from your application. Intel GPA also provides a convenient way of showing System Analyzer metrics in application through the HUD. Real-time overrides can also be applied from within the application using shortcuts. All the shortcuts are quickly within reach through the heads-up display and can be brought up by using Ctrl F1. Graphics Frame Analyzer is Intel GPA's debug and profiling tool, used to analyze the captured frames of a game. It can visualize, replay, and collect all of the information needed to produce any given frame. This includes, but is not limited to, API calls, shaders, buffers, and textures, among other things. This data, in conjunction with metrics and what-if experiments, can help you identify the most expensive events and bottlenecks in a frame. The real-time playback nature of Graphics Frame Analyzer allows you to assess the potential performance gain that results from any modification made to your application without rebuilding, redeploying, or recapturing. If you're already familiar with Graphics Frame Analyzer, the multi-frame workflow is mostly unchanged with only one small caveat. You have to select Stream Capture mode before launching your application. A multi-frame stream will capture all frames during application execution, creating a file that contains a collection of frames. Streams can be opened in Graphics Frame Analyzer by selecting a stream from the selection window. This opens Multi-Frame View, which shows all the frames captured from your application in a timeline. You can select any frame in the timeline to view in the traditional Graphics Frame Analyzer, iterating over the stream to isolate the frames of interest in your application. This is particularly useful to pinpoint problem areas with fast, efficient iterations over data, spot intermittent anomalies, and profile multi-frame algorithms. All of this can be done without the need to recapture your application to produce additional data or frames. Graphics Trace Analyzer is a time-based trace capture tool which gives deeper insight into the execution flow of an application and the system. Graphics Trace Analyzer allows you to correlate multiple sets of information within the same timeline by using event tracks. Data is collected from ETW events, which gives us useful information on per-core thread execution, device and hardware queue status, in conjunction with other things. Additionally, Graphics Trace Analyzer will collect graphics API calls, debug event markers and regions, ITT instrumentation, and the metrics available in System Analyzer. Graphics Trace Analyzer captures via a ring buffer, which proves particularly useful if an anomaly is identified and a trace capture is performed. The data will be present in the trace buffer and displayed accordingly in Trace Analyzer, even if the anomaly happened pre-capture. Make sure to follow the links for more information and to download Intel GPA for free. Thanks for watching.
Hey everyone, thanks for watching this video. If you liked it and haven't seen any of our other videos, subscribe to the Intel Software YouTube channel. You can also connect with other developers and enthusiasts in the comments, and we'll see you all next time.